Okay, so let's go ahead and solve for another x and y intercept. So remember, for x-intercepts I let y equal 0. For y-intercepts I let x equal 0. So let's go ahead and find the x-intercept of this linear equation right here, negative x plus y equals 6. So I'm going to plug in 0 for y. That gives me negative x plus 0 equals 6. Negative x equals 6. I divide both sides by negative 1. I get x equals negative 6. So when x is negative 6, y is 0. Let's go ahead and graph this. 1, 2, 3, 4, 5, 6. Here we have negative 6. Now I need to find my y-intercept, right? That's two really easy points that I can find on my line. Just plugging in 0 makes everything cancel out, right? So I'm going to have negative 0 plus y equals 6, and I find that y equals 6. So I have when x is 0, y is 6. So here I go to my y-axis. 1, 2, 3, 4, 5, 6. So this is when x is 0, y is 6. And I can go ahead and graph this line. Friendly reminder that every point on this line is said to satisfy the equation. Why don't we test that? Because this line was nice and easy to graph. So let's pick this point right here. This is when x is negative 4 and y is 2. And I want to plug that into our equation. So I'm going to have negative x, which in this case is negative 4, plus y, which in this case is 2, equals 6. That leaves me with 4 plus 2 equals 6. Well, 6 equals 6. Good job. That's a true statement. And the same would be true for all these other points. If you want to, feel free to test one. This point right here is negative 1, 5. This point right here is negative 2, 4. All of these points would work. Now, what if I'm given an equation like this, and I need to find the x-intercept? So for the x-intercept, I let y equal 0. Well, is there a y here? Oops. No. So if I let y equal 0, x still equals 4. So I have when x is 0, y is 4. Sorry, when x is 4, y is 0. That's our point right there. But now I need to find the y-intercept. And for that, I need to let x equal 0. Well, that gives me 0 equals 4 if I plug in 0 for x. Is this a true statement? This is a false statement. That means there's going to be no y-intercept. Well, how could something never cross the y-axis if it was parallel to it? We're going to be building up to this a little bit. But remember and keep in mind as we move forward that x equals 4 or x equals any constant, the graph is always going to be a vertical line. And this vertical line will never cross the x-axis, so we'll never have an x-axis, an x-intercept, because they are parallel, spelling, question mark. Now, what if I have something like y equals negative 6? Well, for my x-intercept, I need to let y equal 0. So if I have 0 equals negative 6, is this a true statement? No, this is false. That means it's never going to happen. So that means there's no x-intercept. How could that be? Well, remember when we had our graph of our line x equals 4, because our vertical line was parallel to the y-axis, right? It had no y-intercept. This one has no x-intercept because it's parallel to the x-axis. Let me show you how. I'm going to try and find the y-intercept. For the y-intercept, you let x equal 0. Well, conveniently, sorry, my marker is drawing a lot different today than normal, guys. Okay, so conveniently, there's no x here, so I just get y equals negative 6. So my y-intercept, so when x is 0, y is negative 6. So I go down here to negative 6. This is the point on my line. Now, I want to make this statement true, right? So every point on this line would satisfy my equation. Every point over here, I have y equal to negative 6. Here's when x is 3, y is negative 6. Here's when x is negative 6, y is 6. negative 6. So every single point would satisfy this equation. So my graph is going to be a horizontal line. It's parallel to my x-axis.